Rivers run deep with history. Epic tales of the landscapes and societies that neighbor their shores, not to mention their own winding heritage. These old channels are paths the Mississippi River has taken in the past. At one time, its waters even flowed into the Atchafalaya River. For decades, the Mississippi River has tried to carve its way back to the Atchafalaya River, practically bursting at the seams through what's called an avulsion. A river avulses or breaks its banks when sediment chokes up its channel and reduces its carrying capacity, enough that the water is forced to find a more efficient path. The U.S. Army Corps of Engineers has kept the river in check using a combination of floodgates and levees called the Old River Control System. Human engineering might have brought this river to heel, but it requires constant vigilance, and not all rivers are so compliant. In 2008, levees on the Kosi River ruptured. The flood swept across India and took more than 400 lives, while displacing another 3 million. In the aftermath of the flood, the Indian government built even more levees. River scientists now say that higher levees may actually do more harm than good. That's because they constrain a river and force it to dump sediment within its channel, raising its riverbed and reducing the amount of water it can safely carry. Using models and laboratory tools called stream tables, researchers are getting better at understanding when and where an avulsion might occur. There are two key hotspots. The first is at the foot of the mountains, where rivers slow down. Models show that in this region, the slowing rivers tend to drop sediments and silt up their channels, leading to an avulsion. But what about river deltas, where slope isn't a factor? Here, the interaction between river flow and ocean tides determines where the river is likely to avulse. Flooding in the lower parts of the delta washes away sediment, setting the table for avulsions upstream, at the head of the delta. Scientists modeling the Mississippi River have found that its natural avulsion point would be right near the Old River Control. While promising, these models can account for human effects, like deforestation upstream, which adds silt to the river, or climate change, which is raising sea levels. And structures like levees and gates will only age and fail with time, making long-term solutions critical. Along China's Yellow River, engineers are pursuing soil conservation projects and ways to flush out sediment deposits. Better predictions could lead to better solutions, perhaps grounded in lessons we've learned from the complex history that links rivers and people.